Okay, so we're going to begin our discussion of asymptotes. And asymptotes, there's actually several types of them, but we're going to start with the vertical asymptotes. And it's a little bit daunting at first because we have all this funky function notation in here. So I'm just going to read this through, and then I'll explain exactly what this means. And the function notation, I mean, we have to write it this way so that it's precise and that all mathematicians can understand us, but it makes it look a little bit more complicated than it really is. Okay? So the statement says, if the limit of f of x as x approaches a from the left, this little minus symbol here really means coming from the left. Okay, so if the limit of a function as x approaches some value a from the left is positive infinity or negative infinity, okay, that's one scenario. Or if we approach the function from the right, and that's what this plus sign here means, is also positive infinity or negative infinity, then the vertical line x equals a is a vertical asymptote. Okay, and if that didn't quite make sense, don't worry. We're going to illustrate that with this example here. So here I have a function, and this function is f of x equals 1 over x plus 3. Okay, this is the graph of the function. And let's just see some of the properties of this graph here. That notice here that I'm walking along the graph from left to right, so coming from the left, okay, coming from the left, and this is what this x approaching a negative really means, is that I'm coming from the left, and as I get closer and closer to the right, I hit this line here. It's like it's a barrier. The graph can get closer and closer to it, but it can't actually touch this line. So the closer and closer. And another thing is, if you notice, this arrow here is going down. So the closer and closer I get to this dotted line, this imaginary dotted line, the graph actually, the y values go towards negative infinity. Okay? And let me illustrate that with my graphing calculator. So I've typed in the function 1 over x plus 3, and I have to put x plus 3 in parentheses if I want to do type it into a calculator. And I hit graph, and I hit trace, and I'm going to start tracing from the left. So I'm going to go from -10, and I want you to pay attention to what's happening to the y values as I move closer and closer to the right. So you can see here. Okay, notice what direction those y values are going in. So they're going farther and farther away from 0, and they're going downwards. They're actually dropping. So you can see that it's moving towards negative infinity. And you see, I can get very close to the line, and the graph shows that I'm touching the line, but I'm not really doing that, and I can prove that later. Okay? But I'm getting closer and closer to the line without actually touching any of it. Okay? And now on my calculator, if I go another step to the right, it actually jumps to the other side because it's programmed to do that. But on a real graph, if I were just to continue walking along this path, it's going to go downwards forever. Okay, so that's what this first statement means. As the x values get closer and closer to, in this case, this is x equals -3. Okay? As I go down towards this direction, I try to move closer and closer to the dotted line. The graph is actually going downwards towards negative infinity. Okay? Now watch what happens as I try to do the exact same thing, but only this time going from the right side. Okay, so if I start all the way over here and I walk along this curve towards the dotted line, and you know the rule is I have to stay on the curve, I'm going to get closer and closer in my y values to positive infinity. Okay? The x values is getting closer and closer to x equals -3, but the y value is moving ever closer to positive infinity. And I'll illustrate that again using my graphing calculator. I'm going to hit trace, and I'm going to start on the right side here. I'm going to start all the way over to the right. I'm going to start at about 8. Okay? And so you can see the y values are pretty small. It's about 0.9. And so I walk closer and closer to the left. I move my arrow key to the left and watch what's happening to all of my y values. Let me make this a little bit darker. Okay. So you can see here that my y values are increasing, and it's getting, it's getting close to 1. It's going upwards. It's going upwards. And you can see here on this graph, the graph is programmed so that I can jump across the asymptotes. But in reality, if I were to really walk along this path, I would walk along it forever and never actually make it across. Okay? And so that's what this second statement here really means, is that as I get closer and closer to x equals -3, the y values go towards positive infinity. And the plus or minus here just means that it can go either way. If I had this graph rotated, if I had a different graph where the picture was turned around, it would approach negative infinity, going from right to left. And I'll show you a picture of that graph in just a minute. Okay, so now here I have another graph, f of x equals -1 over x minus 2. And you can see if I look at the two graphs, the orientation of these curves are a little bit different, but the moral of the story is that they still approach, the y values still approach positive infinity as I get closer and closer to this dotted line. Okay, so once again, if I try to get closer and closer to this dotted line from the left this time, it gets closer and closer to positive infinity. As I get closer and closer to the line from the right, so it's a little confusing. I'm going left, but I'm coming from the right. It gets closer and closer to negative infinity. Okay, and looking at this notation, this is what plus or minus infinity means. It means that you can either, going from left to right, go downwards, or going from left to right, go upwards. But as long as it's approaching either negative infinity or positive infinity, then this line here would be the asymptotes. So in this case, the vertical asymptote of this particular graph is x equals -3, because that's this dotted line here, this dotted vertical line. Okay? Pause the video and see if you can figure out what the vertical asymptote is for this one. So the vertical asymptote in this case is x equals +2. That's this vertical line. There you have it. Again, the main idea behind vertical asymptotes is that at first it's a vertical line, and the graph gets as the graph comes closer to the line, the y values approach infinity or negative infinity. So as the x values approach the line, the y values either approach a negative infinity or positive infinity. And this notation here with a minus in front just means coming from the left, the plus coming from the right, and both will satisfy the definition of a vertical asymptote, whether it's coming from the left and going down or coming from the left and going up. The vertical line that it's approaching, that's your vertical asymptote. And we're going to look in a minute. We're going to look at and see just how we can find the vertical asymptote of a graph.